Today we're going to be talking about the renin angiotensin aldosterone system and the antidiuretic hormone. When we started this series, we talked about this system as one of the hormonal ways that the body regulates blood pressure. Today we will be breaking this down so that you can understand this aspect as well. Hello and welcome back to Chronicles of Elena. This is part 3 of a 5-part series on blood pressure. If you've not watched the first two, I would encourage you to go and watch them on baroreceptors and blood pressure. Everything in those ones build up to this one. So for you to understand this better, it will be good for you to go and watch the first two. The link will be in the description box below. However, if you're just looking to know about the renin angiotensin aldosterone system or about the antidiuretic hormone, then this class is also for you, because after this class, you will start to understand it a lot better. The RAAS is a more long-term control of blood pressure than the baroreceptors. There are certain things that trigger this system to be activated. When we're talking about baroreceptors, if you remember the low pressure baroreceptors, one of the things that it triggers is it increases the secretion of renin in cases of low blood pressure, and it decreases the secretion of renin in cases of high blood pressure. So one of the things that trigger the system is the low pressure baroreceptors. The sympathetic nervous system plays a key role as well. And if you have looked at our lesson on baroreceptors, you will get this. So with the sympathetic nervous system, the low pressure baroreceptors, once they pick up on a low blood pressure and the low blood volume, they send the signal to the sympathetic nervous system, which now triggers the kidneys to release renin. So both of them work hand in hand. The next thing that triggers this system is reduced sodium delivery. So when there is a low blood pressure, there is reduced blood being supplied or delivered to the kidney for filtration. With reduced blood, then that leads to reduced sodium, because sodium is one of the components of blood. Once the macular dentin of the kidney senses low sodium, it triggers it to release renin. Renin is being released by the juxta glomerular cells of the kidneys. So once the kidneys sense that, oh, I'm not getting as much sodium, that means that there's actually a low blood volume being supplied to us. And so it triggers the release of renin, which kickstarts the RAAS system. Moving on to renin. Renin is the first thing that is produced in the renin angiotensin aldosterone system. I like to call it the initiator of the system, and that's because once renin is produced, it kickstarts the other mechanisms, the angiotensin and the aldosterone. So renin is produced by the juxtaglomerular cells of the kidneys. Once low blood pressure is sent, the first thing that the low baroreceptors do is they go to the sympathetic nervous system, lodge this complaint. The sympathetic nervous system triggers the kidneys to produce renin. The next thing is, with low blood pressure, there is low blood volume being delivered to the kidney, invariably leading to low sodium reaching the kidneys. And the next thing the kidney does once it senses this is it produces renin in response. So once renin is produced, that has already started the renin angiotensin aldosterone system. So what it does is it converts angiotensinogen into angiotensin 1. So angiotensinogen is like the parent of angiotensin. It's the inactive form of angiotensin, which is already in the blood. It is produced by the liver and it's just in the blood, waiting. It's just flowing in the plasma, waiting for when it's needed. And when it's needed, which is in cases of low blood pressure, renin converts it to angiotensin 1. Now we move on to angiotensin. So once renin converts angiotensinogen to angiotensin 1, that is the end of its role. You now wait for angiotensin to continue the next step in the process. And that is why it is a system. So something leads to another, and another thing leads to another. So angiotensin is a potent vasoconstrictor. Once angiotensinogen is converted to angiotensin 1 by renin, It is further converted to angiotensin 2 by angiotensin converting enzymes, which are produced by the lungs. It's actually produced everywhere else, like in the endothelial cells of the heart, the liver, the spleen, but majorly in the lungs. That's where this enzyme is produced. So angiotensin 1 gets converted to angiotensin 2, mainly in the lungs, by angiotensin converting enzymes. So angiotensin 2 is the active form of angiotensinogen. Remember we said angiotensinogen is the inactive form of angiotensin. There are still other forms of angiotensin. There's angiotensin 3, there's angiotensin 4, and there's angiotensin 5. However, angiotensin 2 is the active form. It is the actual vasoconstrictor that does this job. So once it's converted to angiotensin 2, which is its active form, what it does is it leads to the blood vessels constricting, increasing systemic vascular resistance, leading to an increase in blood pressure. If you remember, when we talked about blood pressure in part 1, we talked about how blood pressure is a direct product of cardiac output and systemic vascular resistance, which means an increase in cardiac output or systemic vascular resistance will invariably lead to an increase in blood pressure. And the decrease in cardiac output or systemic vascular resistance will lead to a low blood pressure. Therefore, once angiotensin 2 triggers vasoconstriction in the blood vessels, it increases systemic vascular resistance. And once systemic vascular resistance increases, it increases blood pressure, which is the key action of this system. Another thing that angiotensin 2 does is it triggers the adrenal gland to release aldosterone. The adrenal gland is seated as a cap. It looks like a cap on the kidneys. So if this is the kidneys, this is the kidneys. What is it now? You must pardon my diagram. I'm not very good at drawing. Anyways, so if this is the kidneys, the adrenal gland is seated like a cap on the kidneys. So the angiotensin 2 triggers this adrenal gland to produce aldosterone, which is the next step in the renin angiotensin aldosterone system. Another thing it does is it triggers the hypothalamus to tell you that you're thirsty. Remember that when you're thirsty, you drink more water. Drinking more water increases more blood volume. More blood volume increases cardiac output, leading to blood pressure increase. Now, to summarize the functions of angiotensin, the first thing it does once it's converted to its active form, which is angiotensin 2, the first thing it does is it causes vasoconstriction in the blood vessels. The second thing, it triggers aldosterone release. And the third thing, it triggers thirst. So it goes to the brain and says, you need to drink, you need to drink. And the brain tells you, all right, you need to drink more water. You go on to drink more water. So dehydration leads to low blood pressure. And the first thing we do, like in the hospital, once we notice that, oh, okay, your blood pressure is dipping, we say, oh, okay, you need to take some more water. What are we doing when we're encouraging the person to drink? We're simply telling the person, you need to increase your blood volume. Once the blood volume increases, it increases cardiac output. And once that happens, it can lead to an increase in blood pressure. Now, this is in absence of every other condition, such as hemorrhage. So now we go on to the third step of the RAAS, which is aldosterone. Aldosterone is produced by the adrenal cortex. The adrenal cortex is the outer layer of the adrenal gland. So it's basically produced by the adrenal gland, which I have said sits like a cap on the kidneys. And the aldosterone is a hormone that causes the kidneys to retain sodium and water. Retention of sodium would lead to retention of water to dilute the sodium. In addition, the kidney also retains even more water apart from the sodium. What this does is it increases the blood volume. So it tells the kidneys not to excrete sodium, and as much water. Once these two are retained, it pulls more water back into the circulation, increasing blood volume and cardiac output, leading to an increase in blood pressure. The aldosterone also does other things like electrolyte balance because it tells the body to excrete potassium and retain sodium. It also plays a role in producing hydrogen, which helps in acid base balance. But for the purpose of this class, we're only focusing on its role on increasing blood pressure, which is retaining sodium and water, leading to an increase in blood volume and cardiac output, leading to a blood pressure increase. Now, when there is when there is a lot aldosterone being produced. Say, for example, there is a tumor of the adrenal gland and it's leading to the adrenal gland producing a lot of aldosterone. What do you think would happen? Knowing that aldosterone leads to more sodium retention and more water retention. So that means if it's being produced in excess, there would be a hyperactivity of these functions that it does. So it would lead to things like hypernatremia, which is excess sodium being retained in the blood, and invariably lead to high blood pressure as well. And low aldosterone would lead to low blood pressure and things like hyponatremia and hyperkalemia. So hyponatremia, more sodium being excreted because the aldosterone is no longer there to say to the kidneys, you need to retain more sodium. So the kidneys are just taking out sodium as they want. And there'll be hyperkalemia because remember, one of the functions I mentioned is it plays a role in electrolyte balance. It plays a role in electrolyte balance. So when there is a deficient aldosterone, there's things like high potassium because it tells the body to remove potassium and keep sodium. So when it's now low, nothing is there to actually tell the kidneys you need to take out potassium, leading to the kidneys leaving potassium in the blood, leading to hyperkalemia. So, like I said, when I started these classes, I said I want to be able to link these things to real life scenarios where you don't have to memorize these things. Once you know the function, you can predict what will happen when there is an imbalance in its production, whether it is a deficiency or an excess. So, like I said, an excess of aldosterone, this is what it would lead to, and a deficiency of aldosterone, this is what it leads to. So this is what the RAAS system it basically is. I'll use a diagram to explain it to summarize this lesson for you. So this is the end of the renin angiotensin system. I've basically explained what the renin does, how it initiates the system, leads to the angiotensin being produced, and what the angiotensin does. And we've talked about the aldosterone and how the aldosterone comes about and what it also does. The last thing we need to talk about is the antidiuretic hormone. The antidiuretic hormone is also known as vasopressin. It is produced by the hypothalamus and stored in the posterior pituitary gland. It is now from the posterior pituitary gland that it is released into the system when needed. You remember when I said that the angiotensin triggers thirst in the hypothalamus? You remember? So once it triggers that thirst in the hypothalamus, it is antidiuretic hormone that it will release. In response to telling you that you're thirsty, it would also release antidiuretic hormone. So, as well as telling you that you're thirsty, the hypothalamus also releases antidiuretic hormone. And what does antidiuretic hormone? From the name, antidiuretic. Diuresis talks about making more urine. Antidiuretic talks about conserving, making less urine, so conserving more water. And you will notice when you're not drinking as much, you tend to not urinate a lot, and that's because your body is trying to conserve water. But when you drink a lot, you end up going to urinate a lot of times in the day. You will end up going to urinate a lot of times in the day, and that's because you've got excess volume and your body is trying to maintain balance by excreting a lot more water. And if not, the body holds on to water. What makes it hold on to water? That is vasopressin or antidiuretic hormone. So you see how these things relate. So the antidiuretic hormone is produced in response to the low blood pressure baroreceptors as well as angiotensin 2. Its function is simply it allows the kidneys or it tells the kidneys to conserve more water, reabsorb more water. It leads to an increase in blood volume, leading to an increase in cardiac output, leading to an increase in blood pressure. So you must understand, once you can see how the functions relate to the blood pressure, every single one of the techniques that we're talking about looks at either increasing this vasoconstriction, which is systemic vascular resistance, or the blood volume, which is cardiac output. Any of these things that are increased would lead to an increase in blood pressure. So let's summarize this using this diagram. I want you to remember this diagram. If you take nothing away from this class today, take this diagram with you, because once you understand this diagram, you've understood everything we were talking about before. Once there is a low blood pressure, it is picked up by the kidneys and the low pressure baroreceptors. The kidneys pick this up because of what? Reduced blood volume and reduced sodium. So it triggers. The baroreceptors pick it because that is their function. They are close to the heart and they dictate it via stretch. Again, these baroreceptors are explained in the part 2 of this series, and the link will be in my description box. Do well to watch it. It is a very educative video and lesson. So once this is picked up by the kidneys and the baroreceptors, they trigger the kidneys to produce renin. Renin goes to angiotensinogen, which is already in the blood. It acts on this angiotensinogen that is flowing in the blood, and it's just flowing on its own. The kidneys produce renin, which acts on it, converting it to angiotensin 1. Angiotensin 1 continues going around in the body and reaches to the lungs, which is where it is majorly converted. The cells that produce the enzyme is a lot more concentrated in the lungs. So a lot of angiotensin 1 is being converted to angiotensin 2 in the lungs. Anyways, angiotensin 1 continues flowing, and then once angiotensin converting enzymes senses angiotensin 1, it picks it up immediately and converts it to angiotensin 2. Angiotensin 2 is the active form of angiotensin, and angiotensin 2 leads to vasoconstriction. What does vasoconstriction do? It increases systemic vascular resistance, leading to an increase in blood pressure. Angiotensin 2 also goes to the kidneys, stimulates the adrenal gland, and says, adrenal gland, produce aldosterone in response to angiotensin's stimulation. And the aldosterone leads to an increase in sodium and water reabsorption, increasing blood volume, leading to an increased cardiac output and therefore an increased blood pressure. So the ultimate function of the RAAS system is to increase vascular resistance and cardiac output. And once this happens, blood pressure increases, thus regulating blood pressure. I hope that this diagram makes a lot of sense. This diagram and the other pamphlet that I used to describe this RAAS system would be available on my WhatsApp channel, and the link will be in the description box below. You can take this diagram, and I want you to look back at it and use it whenever you need to remember. From these descriptions, you have also seen how the kidneys helps to regulate blood pressure. The kidneys produce renin. It is the kidneys that reabsorbs water and sodium. And these key actions lead to an increase in blood pressure and vasoconstriction. So that is how the kidneys play a very important role in blood pressure regulation, which is why when people have kidney failures, one of the key symptoms is that it also leads to hypertension because it leads to this mechanism failing. This concludes our series on the regulators of blood pressure. This concludes our classes on the physiology of blood pressure. Remember, the physiology talks about the normal. So we have learned the normal, the way the body normally regulates blood pressure. In the following classes, we will now be talking about the pathophysiology. What happens when these mechanisms are either overactivated or fails, which is what we now know as hypertension or hypotension. So we'll look at the pathophysiology of hypertension and hypotension in the next class. I hope you're looking forward to this class and I hope that you've learned something from today's classes. Let me know in the comment section. Remember to share this video to whoever might need it. Don't forget to like and subscribe so that when I post the next video, you'll be made aware. Thank you so much for joining me today on Chronicles of Elena, and I do hope that I will see you in my next lesson.